Chapter 4, Lesson 7 focuses on the law of sines and the law of cosines. Okay. Up to this point within trigonometry, we have focused on right triangles. So everything that we have done has only occurred because we have a right triangle. But in real life, the chances of having a right triangle can oftentimes be slim. So we have to be able to work with non-right triangles as well, and those are called oblique triangles. So oblique triangles are triangles that are not right triangles. We still need to be able to find missing sides and angles, and that's where the law of sines and law of cosines come in. So the law of sines is used to solve oblique triangles if given angle, angle, side, angle, or side, angle. Okay. Within the law of sines, we have what's called the ambiguous case, and that is when we are given two sides and a non-included angle, or SSA. Okay. When that occurs, if you recall from geometry, if you are given two sides and a non-included angle, it did not necessarily guarantee congruency because more than one triangle could potentially exist. So when we are given two sides and a non-included angle, we have to determine whether we have no solution, one solution, or two solutions. The law of cosines is used to solve oblique triangles when given side, or side, angle, side. Okay, and we also are going to be finding the area. And one special formula we have is called Heron's formula, and it's used to find the area of a triangle when three sides are known. Okay. Now, the first thing that we're going to do, we're going to kind of jump around a little bit, so just bear with me. But the first thing that we're going to do is find the area of a triangle. Okay. Now, what I would like for you to do first is take out a clean sheet of paper. It's kind of scratch paper. And I'm going to give you a problem that I would like for you to try. Okay, I would like for you to find the area. Okay. Now we're going to take a triangle, and I'm going to label the the angles of my triangle, angle A, angle B, and angle C. Angles are always used with capital letters, and the side opposite those angles are going to be the lowercase letter. So for example, here's angle A, so I will always label the side opposite side A. Here's angle B, the side opposite angle B is going to be side B, so I'll use a lowercase b. I have angle C, the side opposite is going to be side C. Okay. Now, what I would like for you to do is take a few minutes, and I would like for you to see if you can figure out how to find the area of this triangle. Now, as a reminder, area is 1/2 times the base times the height. Okay. Pause the video and see what you can come up with finding the area. When you're ready, hit play. Okay, so we know that the area of a triangle is 1/2 times the base times the height. Now, there's no height in my picture, so the first thing that I'm going to do is sketch in the height. Okay. Now, when my height is drawn the way it is, the base is the side the height is perpendicular to, so the base of this triangle is going to be C. Now, I need to come up with some value for the height. Okay. Now, notice if I cover up the right side, I have a right triangle, and we have methods that we can use to find the side length of a right triangle. So here, if I have angle A, I know H is the opposite side and B is the hypotenuse. Okay, so I know that sine of A is equal to the opposite side divided by the hypotenuse. So if I want to solve for the height, I'm going to multiply both sides by b. So I know b times the sine of a is equal to my height. Now I'm going to transfer that information over here. So I know my height is equal to b times the sine of a. Now I'm going to substitute it in. So I know that the area is 1/2 times my base, which is c, times my height, which is b sine of a. Now, when we write this out, we should always put the letters, especially the lowercase letters, in alphabetical order. So the area of this triangle is 1/2 b c sine of a. Now, what we have done is we have just completed a proof for a formula for how to find the area of a non-right triangle when given two sides and an included angle, or side, angle, side. Okay. So we have the area of a triangle given side, angle, side. It says the area of a triangle is given by the formula A equals 1/2 BC sine of angle A, which is what we just derived, where A and B are the lengths of two sides and C is the angle between them. Okay, so notice there's different variations of this depending on which angle we're given. So we could derive area equals 1/2 AC sine of B, and we can derive area equals 1/2 AB times the sine of C. Now we're going to use these formulas in example 1 to find the area. Okay, so together, letter A, we have angle A is 52 degrees, B is 13, and C is 17. Okay, so I'm going to use area equals 1/2 B C sine of angle A. And I'm going to plug in the values. So area is equal to 1/2 times B, which is 13, times C, which is 17, times the sine of angle A, which is the sine of 52 degrees. Okay, take out your calculator. And I just realized mine's still in my bag, so I need to have my calculator as well. Okay, all we're going to do is plug this in your calculator. Okay, so make sure your calculator is in degree mode. Okay, and we're going to multiply it. So 1/2 is 0.5 times 13 times 17 times the sine of 52 degrees and hit equal to, and we'll go to the nearest tenth. So the area of this triangle is approximately 87.1 inches squared. Okay. All right, I would like for you to try letter B. So pause the video. Once you attempt the problem, hit play, and we'll check our answer. Now, in letter B, we're given angle B is 110 degrees, side A, and side C. So if I use the variations of my formula, then the area is equal to 1/2. Let's see, AC sine of angle B. Let's plug in the values. Area equals, we have 1/2. Okay, side A is 18. And side C is 22 times the sine of angle B, which is 110 degrees. Okay. Again, plug this into your calculator. So 1/2 is 0.5. Multiply that by 18 and by 22 and by the sine of 110 degrees. Hit equal to, and the area is approximately 186.1 feet squared.